Yeah, my name is Blake Doepker. I'm currently a project manager in pre-construction here at Turner Construction. Yeah, just going to talk you through a little bit of a case study we worked on here where we kind of utilized life cycle assessment in our pre-con decision-making process alongside cost. And so trying to basically look at, the whole picture here and incorporate this a little bit more into our pre-con design, pre-con decisions and how we support our design team. So Dave mentioned here that in terms of my background, I spent about 10 years of my career with as a structural engineer. So before that, and then subsequent to that, I've basically been with Turner Construction for about 2.5 years. Kind of in both roles. I recall when I was kind of young and getting into this kind of embodied carbon space, I remember, talking to my, colleagues and whatnot, and a pretty common theme is like, well, it's great you're interested in this, but you really can't do much of it about it from a structural engineer's perspective. And then, interestingly enough, you get into the topic here of you meet with fellow contractors and you start hearing some similar sentiments, and it started feeling kind of like where we were at one point was just we're all kind of pointing the finger at each other. Obviously, this community has really been a kind of a boon to this whole industry here as we kind of proceed with a much more collaborative view on this. And we're starting to realize that, we are all responsible for this, right? And so the goal here is to, when I was with back in my MKA days, was try to kind of reduce and improve our specifications and our business as usual, and trying to apply those lessons learned here from a GC perspective. So, so what are we building? I'm going to tear the Band-Aid off right now. The client is, pretty likes to keep things close to their chest. So actually I sat down with my project executive at the beginning when I was proposing having this conversation. And he said, well, yeah, I mean, it goes without saying, I'm not going to go ahead and mention the project name, the client, what type of building here, building location. So we're going to be keeping it kind of simple. And I did throw out that, this study here is a combination of involves a lot of feedback from a lot of different parties, namely our structural engineer, our architect, and most of all our sustainability consultant. And so I said, well, I want to throw out my some sort of plug to those guys for all their hard work. At which point my PX kind of issued the timeout symbol and said, hey, listen, we can't even share that. So regrettably, for those of you who I worked with, love you, but yeah, we're going to keep it really simple. And so my PX basically said, if we're going to do this, we're going to have to keep this super vanilla. So vanilla it is, but we'll try and add a couple flourishes as we go. So as far as beyond this, the project goals, coming from on high, the owner is set a goal, a requirement for 10% embodied carbon reduction, with the project goal itself being to exceed that and be a 20% reduction. So for those of us in this space, I think we've all probably talked about it at length and basically among the design community and found passion there, but it was always kind of running up against the will of the owners, right? So even if these aren't super ambitious targets, it's really exciting to see this be kind of ingrained in business as usual. And so more than anything, it's just, it's exciting to see that kind of becoming more pervasive in the industry. Okay, so project, it's a full city block podium just for high level and below grade. Phase 1 tower is essentially the massing was somewhat dictated based off of trying to maximize the building height while still without triggering a performance-based design approach, which would impact schedule and also just really isn't right for this particular project to go too tall. So, but to maximize floor count, we're ultimately going for doing a floor-to-floor, the system that allows us the tightest floor-to-floor. So that's a concrete system. So just using a sample rendering, we're looking at a building tower of about 240 feet. So in terms of building height and building type, this kind of really was made sense for our project to be staying kind of within that this realm, the floor count and all that, and the system really was pretty set. Phase 2 is a different story. That building there, the floor plate and floor count is optimized to maximize the allowable FAR in site. In other words, height is not a constraint. So, and that building height thus doesn't really dictate the structural system. So just using some sort of sample mid-rise building, we could certainly play with that floor to floor, different systems, what have you, and it wouldn't really impact the functionality of the project. So in terms of where we started as our baseline, project was essentially a concrete PT slab, 10.5-inch PT, longer spans, more aggressive vibration criteria. That's really what's governing the design. Based off of the programming, essentially, it was really ideally suited for a side core type system, which for the structural engineers in the audience, kind of, you're going to kick yourself into having to add some brace frames out there on the perimeter to kind of manage that torsion. So, but yeah, as I said, basically, because we weren't constrained the same way on the south tower, the owner kind of reached out and said, hey, what are we thinking about potentially, I know we were going down a path with concrete, but what about steel, right? So we worked with our design team to go ahead and craft a couple different studies. For instance, here would be a concrete core with a steel floor framing, slab and metal deck system, and it still has those little wing walls, if you will, or the brace frames on the perimeter. And then finally, we go for the all steel option where we supplement and pull out that concrete core and instead add additional brace frames there at the center. So just one thing of note for these different systems, I already alluded to it earlier, we're looking at different floor to floors, right? So a 14-foot floor to floor for our concrete option, but that's going to have to get pushed for 15.9 roughly for a potential steel option. So from a facade area standpoint, those things need to be accounted for and all that. So typically, as general contractors, we're collectively very good at putting dollars to comparative studies. And I say collectively because I personally am not that great at it, but the estimators I work with are very skilled in this arena. So, and for certain clients, for certain projects, the question might be, okay, what's the cheapest? What's the easiest? What's the fastest? But to our clients' credit, they really wanted to kind of look at this holistically and kind of think about the big picture and beyond just dollars and cents. So our structural engineer on the project actually proposed utilizing a decision matrix of some sort, and this kind of provided us a good framework with which we kind of worked our way through. Giving a snapshot here, the spoiler alert was that our concrete option came out cheaper with the all steel option coming out with the largest premium. The premium was considerable, but not so much to go ahead and say that we absolutely are going to go with the cheapest option. We essentially assessed a whole host of different criteria, right? So speed of construction, compatibility with our brace frames and things like that. Concrete and steel don't always play nice together. And then just kind of impacts if for phase 2, what the impacts to that phase 1 tenant might be. So you can kind of see it's very subjective, coming up with the relative importance and try to just find some way to kind of help create a story. And we, solicit feedback from our architects, MEP trade partners, etc. So, let's see here. So just kind of in terms of just a comparing and contrasting, right? A concrete building, not surprisingly, that's going to be your heaviest building. It's the largest core wall, largest columns, foundations are the heaviest. However, it does have the smallest floor to floor, least facade area goes along with that. Steel framing with the BRB core then would be the lightest. That's the least amount of concrete. And that's the smallest foundations as well. So certainly, but then does have a tall floor to floor. And then the other option there with a concrete core, but steel framing was kind of right there in the middle of it. And so we took this opportunity to add one more line to that decision matrix, namely looking at the embodied carbon. So in this case, what we went ahead and did is we utilized anticipated mixes. So, we worked with our self-perform team to say, hey, like what's our typical PT mix that we've got, looking at, we're still in, early phase design, so we don't know who we're going with, but, looking at the past handful of jobs, what's the, standard Stoneway, Cadman, and Cal Portland mix, and it's kind of trying to inform ourselves there from our life cycle assessment. So that was essentially, not quite like guaranteed which mix we're using. Mind you, these aren't like a high performing mix. They're just your standard run of the mill. And then for steel, we ultimately went with industry average values. And just by virtue of the fact that there's a lot more question about where you'd source it, but there's certainly opportunity for scrutiny there. So when it all came down to it, our life cycle assessment actually yielded some kind of interesting results. We actually found the concrete building performed actually better than the steel option. Note that There's some, some interesting questions about that. I did mention before that we are vibration criteria is a large driver in the design of our floor system. And what we kind of determined by while we're looking at this is really for a 10.5-inch PT slab, that's really appropriate for the slab spans for this particular project. And when it comes to vibration criteria, you're really getting that improvement for free. It's essentially coming along for the ride. Meanwhile, there for the steel options, those are probably heavier than typical floor framings. So it was kind of what we end up seeing is maybe a larger than typical impact due to the steel framing for our particular project. So adding, a couple of different lines to the decision matrix, noting the embodied carbon, I think I'll just, note that this relative importance is really, again, as we said, it's really a subjective topic. I think if you could poll the people in this audience, I think we might, weigh those a little bit differently. But that said, it provided us a pretty important data point. And we kind of laid this out, our design team, GC team, and ownership. We kind of said, listen, concrete here ultimately is the cheapest. Yes, there's a schedule sacrifice. There's some pros and cons along the way, but the third thing out of our team's mouth was like, this is also, we're seeing a winning story as far as embodied carbon goes. So it kind of made the story, the decision ultimately all the more simple. So it was just kind of a interesting exercise to work through. Beyond that, this project right now, again, we are very early phase. What other low embodied carbon strategies are we considering? We're looking at, obviously, a lot of these are nothing too exotic. The specifiers in the room will certainly nod their heads at these, allowing for light strength gain. I think we should also, if those who don't know, one of the first things I do when I open a drawing set is look at those, the general notes for the structural drawings and see what are we looking at for our mix designs. And if you're seeing a foundation mix design that's at 28 days, it's probably worth raising your hand. So that's kind of concrete 101 right there. We're going to utilize higher strength rebar and structural steel where the code allowed by code. Also kind of a no-brainer because typically that's going to be a cost savings to the project, but also worth asking your SE, are you using grade 80 bar? Are we using max high strength steel for our columns? Specifications we're going to be allowing for the utilization of Portland limestone cement. Now, that, mind you, that's pretty much increasingly baseline in the Seattle market, but still, we're starting to see improvements in our concrete mixes just by virtue of that. One I'm looking forward to kind of digging into further with our curtain wall consultant is just looking at a lower embodied carbon for aluminum for our mullions. That one, I know there's going to be a premium associated with that. We'll probably really, I'm looking forward to kind of digging into it, seeing what we can save and laying that story out to the owner. From a procurement standpoint, we're really kind of trying to consider how we can go ahead and start baking in a little smarter procurement of lower global warming potential into our rebar. Other things, as I got a little smarter on the topic, is just finding alternative materials for structural foam and insulation. Maybe there's some things out there that are at a premium, but like in terms of embodied carbon bang for buck, they may be the right choice. And then MEP, low global warming potential of refrigerants, leakage protections, etc. So, and with that, I'll hand it off to Mark.